Alright, so like I said, with these, we're about done with this chapter, so like I said, a little bit of everything eventually we'll talk about will be on the test, and that'll be sometime next week. So we have a lot of sines and a lot of cosines to talk about yet. So we're going to do a lot of sines today, which you have all this. We really focused on right triangles a lot because there's a lot of stuff we can do with right triangles. You can see right triangles a lot in different areas of life, but not everything is a right triangle. So we have some triangles that do not have a 90-degree angle, and they have all kinds of different angles. So what we could use to solve those, we can't use the Pythagorean theorem anymore because that only works with right triangles. We can't use SOHCAHTOA again because that only works with right triangles. We can use the rule that all three angles have to add up to 180 degrees. So that's no matter what triangle we talk about. So we can still use that rule. So if we have two angles, we can still use that rule of 180 degrees of all the angles. But in order to find sides or angles when we don't have two angles or two sides, we have to use either law of sines or law of cosines. So in order to be able to solve this, just like before, I still need to give you three parts. So you need to have at least one side, and then you either need to have another side and an angle, or one side and then two angles. So typically when we work with law of sines, we're going to have more angles than sides typically, because in order for law of sines to work, we have to have a certain pairing. Because the way this works, and we typically use the capital letter and lowercase letter system, where the capital letter is the angle, and the side across from that is the lowercase of that letter. So we always work with that system. Now that's not always A, B, and C. That's how always our formulas are set up, but it doesn't have to be A, B, and C. But it helps you can switch to A, B, and C. But again, the capital letter signifies angle, lowercase letter side, and again, there's always this system where the lowercase letters cross from it. So this is angle A, and then across from it is side A. So this is typically the situations where we can use law of sines and cosines. This is some stuff. This is some lettering and stuff you might have seen in geometry. But typically with law of sines, so law of sines, typically you have to have two angles to work with. So it's either two angles in a row and then followed by a side, or a side that's in between two angles. So I always say typically if you have more angles than sides, you're going to use law of sines. Now every once in a while, you could have two sides and an angle, but it has to be in a certain order. And I'll talk more about that in a second. But then typically if you have more sides than angles, so if you have all three sides, you have to use law of cosines. There's no way to use law of sines. As I said, with law of sines, you need at least one angle. And then, or if the angle is paired in between the two sides, that creates something that you can't use law of sines for. Because the way the law of sines works is you have to have a pair. So what I mean by that is you have to have an angle and it's a side that's across from it. So you have to have that pairing in order for this to work. So if you don't have a pair where you have an angle and its side, you can't use law of sines. So that's what we're going to talk about now. Now officially there are three parts to law of sines. Notice there's, it's set up in ratio format. You do not use all three at the same time, okay? You only use two at once. So say you may only have enough information to use the angle A inside A, angle B inside B. So we only use those two, okay? Or you might have nothing with A, but you know a lot about B and C, so you just use that pair. Or the middle, we don't know B, so we have a lot about A and C. But again, you never use all three at once. So that's kind of what's a little tricky with how law of sines is always written. Is it kind of makes it appear that you have to have all three parts. We only work with two at once. So in order for this to work, because these are actually ratios the way they're set up, you have to have one ratio all filled out. So in order to use one of these, you have to know angle A or side A, or angle B or side B, or angle C and side C. So you have to know one complete pair in order for this to work. Because if you can fill out one whole ratio, then you actually can define what that is. And then say you only know angle B, So then you don't need to worry about C, but you can find side B if you know these two and then that one. So there's always 4 bits of information with law of signs. So you have to know 3 of the 4 in order to be able to use those 2 ratios. Okay? Like I said, you don't necessarily need to know all of it for all 3 parts. But say you know side A and angle A, so then you have this whole ratio filled out, and then you know angle C, so you don't need to worry about the middle ratio. So we put the C in here. What we don't know is side C, so we use a little cross multiplication to find out that side. Okay? So some books write this differently, so you might see in a couple different formats. So sometimes the sign's on top and the little letters on the bottom. It really doesn't matter. I like writing it like this because it matches the poster that I have up here. This is our law of signs. So you really have to make sure you understand the pair. So again, the angle that you have to have a pair where you have the side across from it. So now we're going to just look at a couple of examples. So once you get the hang of it, it's really just some cross multiplication, a little bit of calculator work to find all the missing sides and angles for the triangle. Now a lot of times they give you the triangle, sometimes they don't, excuse me. So sometimes we just need to draw out the triangle first, because I always like to see the visual, other than just having all the sides and angles given to you. So if you're not given a triangle and you want to draw it, you don't have to be particularly creative, but you try to draw an angle where you can envision a 102.3 degree angle. So do kind of a wide angle at the top. So then, once I draw out my triangle, then I say, okay, which angle looks like it could be the biggest angle? That's this one up here. So I'm going to put the 102.3 of the top point of my circle, or triangle. So that's angle C. Where do you want to put angle B?
On the left.
Label that with capital A, or capital A we don't know, so I'm just going to put that over here since I didn't label B or C over there. So I have all 3 angles of my triangle labeled, so I have 2 of them. I can find the third one pretty easily, because again, what do all 3 have to add up to? 180. So that's probably the first thing I'm going to find, but before I do that, I'm going to put the side that I know on the triangle. So since it's side B, it has to go across from angle B, so since here's where we labeled angle B, side B is across from it. So that's where the 27.4 feet. And if you run a little bit next. So then the 2 sides we don't know are little c and little a. So I have my visual drawn. So the things I don't know either A. I don't know angle A or side A. And I don't know side C. So again, I already talked about what's the easiest thing to find first. Angle A. Yep. So I can take 180. I do 180 minus 102.3 minus 28.7. So this angle. At 49. So I know all 3 angles now. And if it helps, I do like to kind of sometimes write it off to the side. I didn't show any work for that. Everyone's good with how I got 49. So we can still use that rule because that works no matter what triangle we're talking about. But now, since it's not a right triangle, because none of my angles are 90 degrees, I can't use SOHCAHTOA and I can't use the Pythagorean theorem. So that's where we're going to use some of our new rules, which today we're just focusing on law of signs. So in order to use law of signs, you have to look at your triangle and ask, okay, do I have a pair where I know both the angle and the side? Yes. Yep. Okay. Because we have angle B and side B. So as soon as you know that I have that pair, I have an angle with its corresponding side, that tells me I can use law of signs. Okay? So then how I set it up first is since I know angle B and side B, I'm going to fill angle ratio. Okay, that's the only thing I'm gonna write down right now. So the side's gonna go on top, and then sine of the angle is gonna go on the bottom of that ratio. So I know 27.4, and then sine of my angle B is gonna go on the bottom. Okay. Now what I like to do is leave it as exact as possible because we actually know everything, so we could go ahead and divide that out if you want to. But I'm going to leave it like that because it's just easier in the long run. So now, here's where we get a little bit of a choice. So I just need to pick another side that I don't know and find it. It actually doesn't matter whether you find side or angle side A or side C next because we know both of those angles. We know angle C and angle A. So we actually could find either one next. So you want to find side A or side C next. C. Okay. So I'm going to put my little C on top because that's what I don't know. I don't know the side. So if I don't know a side, that's what's going to be stay blank. But I do know angle C. So then on the bottom, I'm going to put sine of 102.3. And again, the way the last signs always works is they're always equal to one another. So we have one ratio that's completely filled out because we knew both side A or side B and angle B, and now we knew angle C, but we don't know side C. So that is the only thing we don't know. So now we're going to do a little bit of solving. So when you have a fraction set equal to another fraction, this is where we use cross multiplication. Okay. So if it's a fraction set equal to another fraction, we cross multiply. So we're going to take the 27.4 times sine of 102.3, and then it's going to equal C times sine of 28.7. So I'm going to do 27.4 times the sine of 102.3. And then when you cross multiply, once you do the first top times the bottom, it's going to equal the next top times the other bottom. So then it's going to equal C times sine of 28.7. I always have a long equation to solve. Now, if you want to, the next thing you could do is go ahead and type this in your calculator, 27.4 times sine of 102.3. But the nice thing is, if you leave it in kind of sine format, the calculator does a good job of being able to type it all in at once. So I actually leave it all in sine format, because again, just with the use of parentheses, you should be able to type it in all at once. So our ultimate goal is still to solve for our variable. So our variable here is C. So how can we get C by itself if it's being multiplied by sine?
Divide.
Yeah, we're going to divide the sine. So then now C is by itself, so I just need to do a little bit of calculator work to figure out what C is. So I'm going to take 27.4 times sine of 102.3. Like I said, just use if you're using one of my blue calculators, all you need to do is just close that parenthesis, then hit divide, sine of 28.7, and then hit equals, which is 55.7. And we are going to label, so all of our sides are in. And that's sides. Any questions on how I got that? Now we're solving right triangles. Once you found a second side, you got to be able to pick. You could use the same thing, or you could switch and use the Pythagorean theorem. One thing I'll emphasize is the Pythagorean theorem only works with right triangles. So in order to find the third side, we actually need to use law of sines again. Okay, so we're going to pretty much set it up the same way. And I continue to use, I'm going to box out some room for me to do this. I'm going to use that same ratio I used to find C, because I still know both B values. You actually know both C values, so if you really wanted to, you could switch and use C. But for me, a lot of times what I do is I set up both ratios to start with, and then I solve both of them at, solve one, and then quickly quickly go and solve the other. So I'm going to still use that ratio with the b's because I know both of those. So now I'm going to switch though. Instead of finding side C, I'm going to find side A.
So really the only difference is now instead of multiplying by the, or dividing by sine of 28.7, it's sine of 49.
So you have to solve for everything?
Yep, we're finding all missing sides and most of them. I didn't leave myself a ton of space because I wrote this a little bit too big, but this following, okay. Okay. So now we're pretty much doing the same type of thing. Once you set up your law of sines, we're going to cross multiply. So we'll take 27.4 times the sine of 49. So really that's the only thing that's going to change is instead of sine of 102.3, so now we're going to be sine of 49. And it's going to be a times sine of 28.7. All the divide by 20 sine of 28.7. And then that'll be what 27.4 sine of 49 divided by so it's 43.1. And now we've solved that triangle. And you don't have to write it on the triangle, I just like to. But all three angles and all three sides. Questions about the first one? Okay, so like I said, essentially with non-right triangles versus right triangles, if you have a pair, so you have an angle and a side, instead of having to use SOHCAHTOA or Pythagorean theorem, we have to use law of sines. Now, if you don't have a pair, that's when law of cosines comes into play. So for the stuff we're working on today, you should have a pair. Sometimes you don't have a pair right away, but there's a way to fix that. That's what we're going to talk about next. But again, in order to use law of sines, you have to have a side with its matching angle. So you have to have that pairing in order for this to work. So let's do, I think I just have the one more example. And then we'll look at law of sines. I do like the visual. So we got 98 degrees is our biggest angle, so I'm going to put it down here. I need to draw the same triangle each time. It doesn't matter. So I don't know side B this time, so I'm labeling that angle B. So side B is a cross unit, so that's one of the sides we don't know. Where do you want to put the 43?
To the right.
So that's A, and we don't know angle or side A. So that's the other one is C, which we don't know, and then we know side C though. So I'm gonna label that a cross unit. So that's angle C. So if you look at our information originally, do we have a pair? Do we have an angle and a side? No, we don't. Is there a way we can fix that though?
Yeah.
Yeah, because we have side C. How can we find angle C?
Take two angles out
Yeah.
and then right 180.
Right, so we can subtract it. So you add these together and subtract it from 180. So we can figure out that that angle is 30. Okay. So we already know the third angle. Now do we have a pair? Yep, so now we know angle C and side C, so we can use law of sines. So as long as you notice that we have a pair with an angle and a side, we can use law of sines. So we're going to set up the one that we know. we know side C, so the side goes on top, and then it's sine of the angle on the bottom. And then it's your choice. It doesn't matter if you find A or B first, because you're gonna have to use law of sines to find either one of them. So do you want to find angle A, or sorry, side A or side B first?
Okay.
Okay, so put A on top, and then A's angle is 43. We're gonna do our cross multiply. We have 2.2 sine of 43 equals A times sine of 39. And we'll divide the sine of 39. So once we do that, that's a 2.2. So 2.2 sine of 43. Close the parentheses and divide sine of 39. 2.4. Yep. And label. So we're in feet again. It's not always gonna be feet, but I mean generally default. There's A. Now we're gonna use the exact same type of setup, only now we're gonna switch and find side B. So instead of using 43, we'll use 98. So I'm still gonna use the C pairing. Like I said, if you really want to, you can switch and use A now, because technically we know all of those, or those steps here too. One thing you can use to kind of check your work with sides, again, the biggest side should always be across from the biggest angle. So this should be our biggest side, because 98 is our biggest angle. The other two are fairly close in size, 39 and 43, so it should make sense that they're close, but again, 43 had a bigger side of 2.4, and 39 had the smaller side of 2.2, so this should be our biggest side because it's our biggest angle. So we have 2.2 times sine of 98 now, equals B times sine of 39, and we divide the sine of 39. So whatever we get there, that's what B will be. So 2.2 sine of 98 divided by sine of 3. So we get 3.5.
We have to show the cross multiplication every time. If we like know that it's blah 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 times whatever over.
Yeah, usually, if you show me the setup, I'm usually kind of lenient how much after that you show. As long as you showed me what your setup was, you get that. Alright. Any questions? Not too bad, just different. Law of sines, really nice. Law of cosines, you have to use it sometimes, but we'll talk about that then.